I'm here. I'm here for the duration.
Excellent. All right. So, welcome back to Coding Bootcamp. We are in week 6 of 6. We're in advanced topics and next steps. Today is our last day. We're on day 12. So, we're going to be talking about version control systems and collaborative coding is going to be the main focus of today's um, course, today's class. We're going to talk about Git specifically and pretty in detail about what that is, not in depth into this, all the things it can do, because this could be an entire course just by itself. It does a lot. Um, Before we dive into that, let's just review what we've done up to now, right? We at the beginning, if you remember on day one, promised that we would do a certain set of things, that we would do the same things as coding bootcamp. I guess we can't really assess that unless you go and take a paid coding bootcamp and then compare the two. And every class is going to be different. I do recommend you do that, but again, don't pay out of pocket. Find an organization that'll pay for veterans or subsidize for veterans to do it and do it that way. If you're still interested in learning something else, I highly advise it. But there's plenty of free stuff out there. So hopefully we've pointed you in those directions. Well, we definitely did this tangible objective. The second one, building a fully functional web app from scratch. We did that 100% for sure. Like we finished that up last time, did all our CRUD operations. The intangible objective of demystifying coding is something I can't tell for sure until you tell me, right? So we're going to send out some feedback forms and ask for feedback from everybody that signed up, whether you made it to classes or you're following online, you couldn't come to class, whatever the case may be, makes no difference. If you registered and you've been receiving the documentation up to now, we're going to send you a feedback form, and we really, really, really appreciate all your feedback. Um, positive feedback is always great, but I prefer negative feedback because it helps me improve. So we'll use your positive feedback for our like marketing materials to tell everybody what a great job we're doing, get more people to come in. But the negative feedback is really going to tell like, I say negative, but the stuff that we could improve on is really the kind of things I'm looking for. So please don't hold back. You will not hurt our feelings since we don't have any. And we aim to improve this course. And so your feedback is really helpful. So let us know if we were able to hit this objective of demystifying code for you. But again, I know that we gave you the tools to build anything because we pointed you in the right direction. We walked through the use of them and we showed you all those things. So we did hit all these marks. And just again, a refresher of what we did, week one, we started talking about how computers even operate at the very lowest level, what they're doing with binary, how they understand the things we write in. We did some syntax of Python. Week two, we went through algorithms and data structures. We, made peanut butter and jelly sandwiches and we solved some problems with it. We talked about all the different ways that data can be arranged. And then weeks 3 through 6, really, since we wrapped up on Tuesday, we built our app. So we spent time going through development foundations in week 3, talking about how the internet works all overall, set up our backend stuff a little bit. Then we dove into some front end design development, did more backend things with database in week 5. And then we finished up our CRUD operations at the end of week 5 and earlier this week. And so now we're going to finish up the entire class. Again, I recall this part because we did these 4 operations: create, read, update, delete. And this again is the thing that is in every application everywhere. It doesn't matter if it's web application, desktop, mobile, they all do these things. So, Netflix, Airbnb, you're creating videos or, playlists or, places to rent or whatever. Reading, updating, deleting, that's all anything is doing in technology, right? So we did all those things, and keep that in mind that that's what it is going forward. So today, version control systems, collaborative coding. We are going to talk about these 2 things. And collaborative coding really is dependent on version control systems and how they operate. So we're going to start with talking about how version control systems work, what they are, what they do. And then we'll talk about their use for collaborative coding. And that's the piece I sent out some pre-work earlier. Michael, we were talking about this a little bit beforehand about setting up the SSH connection in Python Anywhere so that you can move things between GitHub. And if you weren't able to do that before now, that's fine. You'll be able to do most of what we do today in class without that. It'll just be like the last little bit of moving things in between. The collaborative piece specifically will be a little bit tough if you haven't done that, but you can just do that later and practice moving things around. So with that, let's dive in. First of all, we're talking about version control systems. We talk about what versions are and what versions even mean. So there's a really common thing out there called semantic versioning. And semantic meaning, just it has meaning, right? So as language nerds, we like to talk about semantics as how humans ascribe meaning to things. And that's what it's saying here. So it's the typical 2 or 3 numbers that we see a lot of times, version 1.7.9 or something like that. Those 3 numbers mean something. The first number is the major version. then a dot, then the minor version, and then a patch version, right? So these are all version numbers that are specifically giving us some sort of information that means something very specific, right? So the major version typically means that it has new features. It's got something that's brand new. It's a major update. That's why it's called major. And it is typically not backward compatible, meaning if you have a version 10, it will not work with version 9 or 3 or any of those things. So if you have version 10.2.1, it won't work with version 8.7.3 or 8 point whatever, right? So major versions do not work backwards with each other most of the time. Unlike the other versions, minor versions could have new features, but they are typically backwards compatible, right? So it's not as huge of a change as a major version. Usually they're backwards compatible. That's not always the case. Sometimes there are things that don't work quite as well in one version versus another. So, for example, in Python, there was version 3.10, and then it moved to 3.11 and 12 at one point, and things in 3.12 don't quite work exactly the same as in 3.10. So you might run into some backward compatibility issues with minor releases or minor versions, but typically they're backwards compatible. So that is kind of one of the things that's separate about major and minor release or version numbers. And then the last number, the patch, is typically not new features. It's mostly just bug fixes or patch fixes, right? So just fixing things. And they're almost always backward compatible, right? So if you have 10.7.3, it'll work with 10.7.2, 10.7.1, all those sorts of things. Should be no problem at all. So if it's within the same major minor thing, the patch typically does not break stuff. It's usually small fixes. So this is one set of ways of talking about versions in the three numbers that we're pretty used to seeing around. The other way it is in the development process, so different steps in the development process. And this is not all encompassing. There's all kinds of ways you could set up a development pipeline, as they call it. But typically it'll have some version of these four stages and maybe some other ones. But there's a development phase, there's testing, staging, and production. And development usually has your most experimental features, your newest stuff that you're playing around with. It may not even work all the way. It maybe buggy and kind of broken and whatnot in different places. Once you move from that into testing, it's going to be the same code base. It's going to be the same application that you're working on, the same program that you're writing. It's just that it's more finished in the sense of you've done all the things that you think it should do, and it works to a point that you're comfortable running it through tests. The testing is to figure out if it works how you want it to. And then it can move into staging, right? So it's still the same code base, but staging is another phase of this insofar as it has gone through testing, it has gone through the development, it's mostly ready to be released publicly if you have public users and things like that. But the production is the final stop. That's like the finished product of wherever phase you're on, right? So these four versions can be the same product, right? So like right now, Google, I'm sure, has a development version. Sometimes you can even access development versions of things, and you'll see the dev version when you download them. And they're just moving through these things into production. What we typically interact with as end users is the production version. But these are all referring to the same code base, same project, same program in somewhat different phases of its development and its progress. That all generally makes sense?
Yeah, perfect.
Cool.
Okay, what's the exact break between a minor fix and a patch?
So it's typically like, that's kind of hard to say. It's a little bit dependent on the people that are doing it and their decisions of it. But again, a minor one is a little bit more intensive than a patch, whereas a patch is like, say something just breaks and it doesn't work, so you go in and fix that problem and then it works again, right? And so that's like a patch. Whereas a minor might be like an update to something, so the functionality is easier for people and buttons are easier to find or something like that. So it didn't add any new features to it. So it's not like a major release. But it could be some really new features. It could be some new features. It could be some really new stuff. But again, typically backward compatible. So there could be some updates and changes, but
so your next minor upgrade would kind of consolidate all the patches, right? So you have a new minor with fewer no patches.
Mm-hmm. Yeah, usually when you move up to a new minor, it's like the patch version will be 0. And then as you make changes in that minor version, it will move up. And then so typically, again, you'll find like the major version will be a lower number than your minor and your patch version, because you'll typically release a major version, like a version 1, and then you'll start making changes to that version 1. So you'll have version 1.0.1.0.0 to start, and then you'll do 1.0.1 because you fixed something small, and then 1.0.2 because you fixed something else small. And then you're like, oh, we need to add like a new page to this or a new button here or something like that. And you decide that that's a minor release, right? So you do 1.1.3 or something like that. So that's kind of how it typically rolls. Does that make sense? That answer your question?
Yeah, perfect.
Cool. But again, it's all really dependent. Even using 3 things like that, like that's not hard and fast. It doesn't have to be that way. People can use 2. There's all kinds of other stuff that can be put on here. You can put alphas and betas and stuff like that, where alpha testing is typically for internal use only and not released to end users, whereas beta versions of things are like still kind of experimental, but they're released to end users for that kind of testing, right? And you could include those here. You could put dates in your versions. There's all kinds of other ways to do it. This 3 number major minor patch is just real common kind of basics sort of thing. But then how those work and what is considered a minor versus a patch is also a little bit dependent on the group, the org, the developers.
Okay.
All right, so that's versions. And so now when we talk about version control systems, it's a system to control those versions, right? And I want to highlight this. I'm going to highlight it several times. You're probably going to get tired of me saying it, even though we don't have a ton of slides. I'm going to keep saying it. All they're doing is tracking changes made to files and directories, right? So let's keep in mind that the overarching fact we've talked about with all programs everywhere is that there are files in directories. It makes no difference what kind of thing we're talking about, Chat GPT, some other AI thing that's coming to take over. It's just going to be files and directories. That's it. That's all it's ever going to be. So version control systems are tracking those changes in the files and directories. There are tons of different kinds of version control systems, but they're broken down into like 3 major groups, I guess. One of the older ones is kind of this local thing called RCS. And this is pretty old. Nobody really uses it that much anymore. It was kind of one of the first version control systems. They moved into a centralized version control system, which is better and it's good in some ways. But the downside of this is that people can't work on it at the same time. Like if you pulled out the code, started messing with it, the chance of me messing with it and then our changes conflicting with each other is really huge. We couldn't really do it that way, so we'd be stepping on each other's toes. So the modern version that we use most often is a distributed version control system. So it's not real important that you know all 3 of these or the differences between them or anything. Just kind of keep in mind that we're using distributed version control systems. And just be aware that there are lots of ways to do it. So we're going to be talking about this bottom one, the distributed version control system, for the most part. Specifically, we're going to be talking about one system called Git, GIT, and it stands for Global Information Tracker. And once you get familiar with this, you can look up the original Git thing and find in the guy's own words who made this, why he called it that, and what it means. It's kind of a play on the word get with GET to go get things. But it says in there, the Global Information Tracker, again, it's just highlighting that it's tracking changes made to files in directories. And when it says global, that just is trying to tell you that it does literally grab everything. So you got to be careful that unless you tell it to ignore something, it's going to grab everything that it has access to. So when you make a Git, what's called repository, it's going to take all the information that's in that directory that you put it in and all the subdirectories that are inside of it, unless you tell it explicitly to ignore something, right? So that's what we're using. Very, very commonly used distributed version control system is used everywhere. I'm sure there are organizations out there using some sort of version control system that's not Git, but I quite literally can't think of one. I don't know anybody that doesn't use Git. Git is absolutely everywhere. Every developer I know, every place I know uses it. So, I don't really know a whole lot of alternatives. But why would we do this at all? Like, why is this something? Why are we talking about Git? Why would we even want to do version control in the first place? So we've talked about what versions are. We've talked about this, the fact that they could be controlled with systems. But why? So again, keep in mind, we're tracking changes made to files and directories. But the idea here is that you can take these things and you can develop experimental features and you don't break your code base. You can save your stuff up in cloud providers, which we're going to talk about soon. You can ensure that the proper version of your code is being used. So you can write different versions of codes. And we talked about the production, the staging, testing, all those things, different versions. You can also do things like A/B testing and make different versions of things for users to play around with and see which ones they prefer, which ones work better. And you can use a version control system to do that, where you have your code base that, you split it into 2 different, what we call branches. and one branch has one set of features, one branch has another set of features, and you test those out. And it's the same code base existing in slightly different ways at the same time, right? So that's what one of the ways the version control system is really helpful. Collaborating with developers, again, that's a huge part of it. So the fact that distributed version control systems enable large groups of people to make changes to the same code base without stepping on each other's toes and having conflict is the only reason that the major things that we all use are even possible. Something like the size of, you know, Instagram or Facebook or any of those sorts of things could not be possible if like one person had to do it or only one person at a time could work on it, right? So collaborating with other people is one of the major values of version control system. And it's also why organizations always use them, right? Is how their development teams work. They work through most typically Git. And it's really good for managing projects of all sizes. So it doesn't have to be, I've talked about huge ones, I've talked about big stuff, and this course is about practical professional skills. This Git is a practical professional skill. It is quite literally mentioned in just about every job post that has technology involved in it, and they want you to know how to use it. But it is exceptionally good at managing any project, right? So it's something I advise you to use on your own projects and everything you do. It doesn't even necessarily have to be coding. Like the way that this thing does it, we can talk about it when it's tracking changes to files in directories. You could be writing a book or, just having text files that you're collaborating on and working with, much like you would do in, say, Google Docs or Dropbox or something like that. You can use a version control system to do that as well, right? So it's good for, I use Git on every single project I do. Doesn't matter how big it is. And I recommend you do the same because it's really good way to save your work, set checkpoints to roll back to. You can experiment confidently and not break the fundamental program that you've written. And then you can do some really cool stuff with it, right? So this is typically the kind of thing that's done in larger organizations, right? So when I say it's good for projects of all sizes, you're probably not going to set up what's called a continuous integration or continuous development, CI/CD as it's commonly referred to, pipeline. That's something that's usually for big organizations and complex projects. But that's made possible through a version control system, right? So what this is referring to is when you think back to the development, testing, staging, production, sort of that would be the pipeline, right? So you start at development, then you move to testing, then you move to staging, then you move to production. Continuous integration and development is an automated way of doing that, right? So as soon as you meet certain criteria that you can set out in your version control system, you could give the parameters to the version control system and say, these are the parameters that we want it to move between these things once it passes these tests or, gets these approvals, whatever the case may be. It can automatically move from one thing to the next. And that's, again, saves big projects, big organizations tons of time to get really complex work done, right? So it's probably not something you can be doing on your own small projects, but it's possible. It's made possible through VCS. So these are a handful of reasons why anybody would want to do what we're going to start doing today. Any questions about this before we move on?
Oh, I got it.
Nope. All right, great. Cool. So let's talk about Git specifically, the Global Information Tracker, or Git, GIT. And this, again, no shock here. It tracks changes made to files and directories. I'm going to keep saying that. I think this is the last slide, but I'm going to say it until we're done with slides. And then I'll probably say this more times after that. But keep in mind, that's all it's doing, right? So it does this by creating what's called repositories. And I put in here that contains the files and directories you want to track. It doesn't really contain them. And I want to make sure that we're clear on where things live and what they are, right? So when we make a Git repository, we put it in the top level of our project. So we're going to put it in our context in the project we've been building. As an example, I'm going to show you we're going to put it in our my site, top level my site directory. And it's not going to contain the files that are in there. It's not going to contain the directories that are in there. It's going to be its own directory in there, but it's going to track all the changes to every file that's in those directories, unless, again, you explicitly tell it to ignore something. So it will track whatever you do, any file you make, change, create, destroy, any of those things. So it allows, again, storage in a cloud provider. So it's very common for people to use some sort of cloud provider to store their Git repositories and make them available for other people as part of the collaborative thing. Now, these things come in all kinds. There's tons and tons and tons of these. We're going to use GitHub, and I recommended signing up for that in advance if you didn't already have a GitHub account. I know some folks do. Sometimes they'll get GitHub accounts, not do much with it, but it's a real common one. There are lots and lots of other ones, right? So there's GitLab, there's Bitbucket, OneDev, and it just keeps going. There's tons of these things. You'll notice that a handful of them, like the top two, GitHub and GitLab, they have Git in the title. That's confusing because they are not Git. Git is its own technology. It's separate. GitHub is a website. GitLab is a website. There are companies, there are places that exist. They used Git as kind of like a marketing thing to conflate their company with the technology. They are not the same. So GitHub is a website that uses Git. It allows you to use Git. Git is its own thing that you don't have to have GitHub to use, right? You can download GitHub, or you download Git for free. You can use it on your computer and never interact with GitHub at all, never interact with any of these cloud repositories at all, and happily use Git, no problem, right? So we are going to use GitHub for the collaborative piece. We're going to use it for what it's good for, and it is very, very common to use. A lot of people use it, so it's good to use. But really keep those separate in your mind. Like, Git is a technology of its own. It's something you can use without GitHub. GitHub is one place where you can use as a cloud provider to collaborate with people and save your stuff and back it up in the cloud, which is also very good, even if you're not collaborating. Again, if you only save stuff locally, then you can suffer catastrophic failure when your machine breaks. If you save it in the cloud, that won't happen. You can pull it down to whatever device you want to. So it is good to do these things, but you don't have to. These are separate, right? Any questions about any of that? That all making sense? All right, cool. So with that, let's go over and get our hands on stuff. That's the last slide where I'm going to remind you that it's tracking changes made in files and directories. So before we go, there's a little more I want to talk about before we go like hands-on. I want to go over to our free coding resources and show you something that's exceptional for this stuff, right? So down under version control, I put a version control section underneath the text editors and integrated development environments. There's a bunch of stuff in here. And it's just under the Git heading. There's a cheat sheet link. And this thing is by far the best thing I've ever found. So, I've been writing, we've been writing these documentations for everything we've done up to now. And I didn't even consider writing my own for this because there's absolutely no reason. This site is all you need to get started. I still use it as a reference every now and then if I forget a particular command. But like I said at the beginning, Git is something that can be very complicated very fast. But this helps simplify it. So when we talk about versioning, before I kind of go into this, one thing I kind of forgot to mention is conceptually we've talked about our app in terms of physical space, right? We talked about it as the analogy of building a building with a plot of land, and we differentiate that space by breaking it up inside of it, not adding things to it modularly, right? It's like a cell dividing within itself. We talked about all those things. When we start talking about version control, we're adding the layer of time to our program, right? So the physical space that we've imagined up to now is the plot of land or the building, if we want to think of it that way. We're now thinking about it in different points in time. So we're it's almost like a multiverse that we're going to start creating when we start doing branching and things like that. So it can get very confusing and complicated. It's very easy to confuse yourself and like make conflicts and make things complicated. So it's good to have a guide like this that very simply shows you exactly which parts and pieces you need to do in a basic workflow without any of the really complicated deep stuff, because it can get very complicated, very deep, very fast. All right, so it shows you again, you can set it up locally on your own device. They've got downloads for the major OS flavors. So if you don't have Git already on your personal device, you can absolutely do that. What we're going to do hands-on here, again, we're going to do it in Python Anywhere like we always have. But, since we're not deploying any of this online or deploying it to the web or anything like that, not super required. You can do this on your own computer if you prefer. But it's already going to be built into Python Anywhere, so we don't have to do this step of downloading and installing. But you're absolutely welcome to do that, and it's totally free. So we're going to go into this creating repository. We'll go through that step in a second. This also is something we're going to do. So it's called checking out a repository. This is how you pull down from a cloud thing. We'll get to that after we go through the basics. I just want to go down to this part right here, which is the workflow. And so this is a really good description of what you do when you're working with Git. So you have a working directory over here on this left. This is this directory picture that they have, and this is where you're writing your code, right? So you're all the things that we've done up to now. This is like our my site directory. Imagine this says my site where it says working directory, right? So we've written our code. We've done all the things that we've done over the last few weeks. And we have our directory that's sitting there. And what we do with something like Git is we do this thing called add, and we add all these the directory and all of its subdirectories. See this little dotted line thing in the next part that says index and stage? That looks a lot like our tree. When we did the tree command, that's what it's adding. It's adding all the things that are in your working directory, subdirectories, and everything that's in there, unless you tell it not to. Everything that's in there is going to get added to what's called a stage, the index, right? So we've used index in another term as like a homepage thing. Think of this as pointers. They're literally called pointers. These are things that are being pointed at, right? So the working directory is one place, And then when we add things into the staging area, that means that it's ready to be what's called committed. And committing is saving it into your Git repository and saving point in time, right? So remember I talked about a multiverse and different points in time. This commit is saying, okay, this point in time is one that we're going to save. It's like taking a snapshot, basically. And that is called the head. So that's the head is where things have been committed and they are saved there. That doesn't mean that it's like working and you could commit non-working code. That's that's fine. This doesn't mean that's fully baked or finished or any of those things. You're just at a point that you want to save it. So that's all this is doing, right? So this is showing the basic workflow that we're going to go through a couple of times now, but you go through it very, very frequently when you're working, right? You do some changes, you add those changes to your staging, you make sure that you got the right ones that you want to add to you want to commit to the thing. That's why there's a break in here, why you don't just save them directly, is because sometimes you don't want to save things. You don't want to commit everything. You just want to commit some of it, right? So there's a staging part where you can look it over, make sure you got the right pieces in there. And then the head, which is where the last commit that you made is going to be. So this again, going through this documentation, how great it is. It just shows the commands that we're going to be using over and over again. These are the fundamental commands we use a lot of times. So this is how you get that done on what we just did. So you literally get is the beginning of everything we're going to do to let it know. It's just like when we did Python commands. We did Python 3 first. Get, you start all your get commands with get. And then when you add files, you just do add, and you say the file name you want. You can also use a period to add everything. This has an asterisk, but we use a period when we type it normally. But so you can add everything, or you can add a specific file. We'll go through those shortly. And when you do this add part, that's moving it to staging. So it'll move it from your working, just not being set up at all, to putting in the staging when you do add. And then when you're ready to commit it, you commit, and it'll demand that you give it some sort of message. So the shorthand to do that is put this little M flag and then just write a string for the message. If you forget to do this part and you just do get commit, it'll pop up with something that says, hey, give us a message as to what you're doing as commit, because it saves that in your log. And that's required. You can't have a blank entry in your log. It has to have some kind of title, right? So usually give the message as some kind of descriptive thing of what you did in that change and what this commit entails, right? Because you change at a certain point. Like you're usually working towards a specific thing. Pushing changes, we'll talk about this. This is, again, interacting with online repositories and cloud-based things, and we'll do some of that. Call this out real quick. Master is the name of the main branch in a Git repository, and it's kind of an old way of referring to it. This is, you'll see this in older versions of Git. I think it's still called that in Python anywhere. So we'll go through renaming it, because a few years ago, probably 8-9 years ago now, everybody started looking at this and they're like, you know what? We don't like talking about this because that's slave terminology. We don't like using things like master and slave. So now the standard is main. Everyone uses main as the main repository thing. So if you use a version of Git that still gives you a master branch, typically is renamed to main. And that's what everybody expects it to be, is main, not master, right? So we'll do that too. It's really easy to rename stuff. I'll show you how to do it because it's useful to know. But this pushing is, again, the online part. We'll go down here to branching, because this is a major part of what we're doing, right? Branching. So here's our master branch, and these things are all referred to as trees and branches and things like that, right? So the working tree is wherever you are, whatever directory you're in, and whatever branch you're on, right? So you start with master over here on this left-hand side. So let's say we want to make some change. Our master file, our main repository is our to-do app that we've been working on, and we want to do something new to it. We want to make some new feature. So what we do is we'll make a feature branch. And you see here where it's highlights and it splits. It says it splits up here and starts running kind of in parallel to the master branch, right? This is showing that these two things exist. Again, think of them as alternate universes. They exist at the same time, but they could be completely different. You know what I mean? So this feature X can be massively changed from what's on this master branch. It can break it entirely and do something totally different. It won't affect what's on the master branch until you get to this other side on the right, where you merge this feature X branch back into the main branch. So there could be several, and this is where it gets really complicated. Again, this is a hyper simplified way of looking at it. This is what we're going to do. And when you're working on small projects or working by yourself, this is pretty much what it looks like. But when you start doing collaborative things with lots of people, there could be one branch here for feature X, and then there'll be a branch down here for a hot fix of a certain thing that'll merge at a different point. And then there'll be several branches and merges that you have to make sure are not conflicting with each other. It can get really complicated, but this is in essence what's happening. That there is one main tree, one main branch of your tree, and you make another one to start fooling around with stuff. And right at the beginning, it's exactly the same. And then kind of at this point, you start writing different features for this feature X thing. And then once you're ready for it, you've done your testing, you're ready to move it back in, you merge it back in. And then from here, after the merge, the main branch and has all the stuff that was in the feature X branch that you made. So from here on, it's got the new stuff in it. This stuff still exists in the past, and you can roll back to it and use the version control system to go back to some version if you find out that, like, after the merge, something ended up breaking. You can roll it back to before you made those changes. There's ways to do all that sort of thing. So again, this is very much like a multiverse where these things could exist at the same time, and you can kind of jump around. It's like time travel. So this all making sense so far? Yep.
Are you, when you do a feature X, right? Is this like a replacement for the master? Or
No,
is it...
it's not. No, they exist exactly the same at the same time, and they're not replacing each other at all. Right. So
okay, well, after you merge though,
mm-hmm.
after the merge step at the right there.
Yep. Yeah. So what happens is that they'll have the same information, but they will still be distinct branches after the merge. Right.
Okay.
So you basically, so let's say we're adding to the to-do app. Let's say we want to add some fields like assignee or notes or something like that to the tasks.
Yeah.
So then we'd make a branch, and then we start adding those things in here. And on the master branch, it would not have those things. It would still just have the 3 things we added to it already with the tag, to do and all that kind of stuff. But then once we merge it, then on this section of the master branch after the merge, it'll have all the new stuff that we added. The feature X branch up here, it'll still exist. It doesn't get destroyed in the merge. It'll still exist over here, but it's not connected to the master. Like if we make changes to the master branch, it won't reflect back on the feature X branch or anything like that. They're always 2 distinct things, but you can take the information, combine them into one, and that's what merging does.
So if you went, if you're in your progress, right? If you're saying, oh, feature X was a big mistake, then can you back it up and say, we're just going to use what's in the main branch and not use feature X?
Yep. Okay. You can roll back to some point in here before you merge this feature X, and it'll be all the code that existed at that point, as long as you committed it at some point, right? Again, the commit is the snapshot in time. Yeah. So as long as you have a commit from before this merge, then you can go back to that commit and you can make the main branch be what it had been before you put the feature in there.
Okay, so it makes sense to commit fairly frequently, right?
Yeah, real frequently. So that whole add files and then commit them, that's real frequent. You end up doing that a bunch of times.
Yeah, okay.
So the creating branch, we're going to go through these mechanics as well. This again, just to kind of show you what's here. And this is a reminder if you don't remember exactly how we do it this time, which, I don't expect you to remember right off the top of your head the first time. And like I've said a bunch of times, I come back to this day to remember how to do things if I forget how to do them, because it's really good. So this is how you make a branch. You get checkout and this B flag and then give it the name. And this is how you change between branches. You use this checkout command. And this is how you delete branches, and just the D flag also with the branch thing. And then we go to rename things. It's also going to be this branch command, but we're going to use M to rename it. But basically the same. So get commands are real simple. They're not a lot to them. So updating and merging, there are a couple ways. So like pull is, again, this pulling down from a remote repository. So pulling down from some sort of cloud-based thing and pulling down what's out there. It's a way that if you say, started collaborating on our project, our hired labs main project, which I really hope somebody from this course does, you will initially clone it the way we're going to clone a training project later today. But then once you have it set up on your local machine or whatever environment you develop in, to update it to get the latest version of that code, you do a pull, right? And the pull is going to pull down the latest code from that thing. So like, again, let's imagine that all of us are working together on something. So the four of us that are on the call right now are working together on a project, and we all go off over the weekend and we all do our own work. When I come in on Monday, I'm going to start by doing a pull to make sure I got all the changes that you all committed before I start working, right? So that's kind of what a pull does, as opposed to a merge, which again is merging in some sort of branch specifically. So like it's going to take some changes that you've done in a specific branch, and it's going to pull those into the branch you're in, whereas a pull will just update the branch you're on from a remote repository. And hopefully this comes a little bit more clear as we go through this. But a lot of these things, like if we keep going down, there are tons of other things that can be done. This has like log information and replacing local changes. We're not going to get into that level of depth of it, right? So this says that there's nothing deep in this thing, but it's going to get deeper than we need to, right? So we're going to keep it just the kind of what I've shown you thus far, and we're going to get hands on this and set it up. But I want to show you this as a really good resource to refer back to as you're messing around with these things, because it has the commands exactly. It has good explanations, good visuals, and it's really simple to use. And this, again, is linked in the free coding resources down by the version control and Git. All right, so let's start playing around with it. We're going to go to Python Anywhere, and we're going to start doing some stuff with Git. And we're going to do that in the console. So we shouldn't have to mess around with any files or anything like that today. Let's get out of here. Now I apparently was lazy and didn't deactivate or close any of the stuff from before activating my thing. So I'm gonna do that now, because that's terribly lazy of me. And we need to just go through. I'm gonna go through the beginning phases like we normally want to reactivate those things, because again, it's practice, it's habit, it's what we should always do. We're not going to be doing anything with our virtual environment specifically, but because we're going to still be working on the project that we were using as an example for Git, I'm going to do the same steps that we always do, right? So I'm going to activate our virtual environment. So I do source bin, name of the virtual environment, bin, activate. And then I'm going to change directories into the top level my site directory, right? So here we are. And this, again, probably okay if we didn't do the virtual environment specifically. We're not going to be doing anything with packages, but this is just good habit to get started with every time you get going on your day of working with any of these things, right? So if we're working on the same project, we activate it the way we always did. All right, so now we're on our top level my site directory. And as I mentioned, Python Anywhere already has Git built into it. So we can prove that by doing Git and then 2 dashes and then just the word version, and it'll tell us the version that we have. And this is true for anything that the 2 dashes version, or 1 flag and V sometimes works. I usually do the explicit one because that works more often, tends to. You can do that with just about anything. It's not a Git specific. Like you do that with Python, you can do that with whatever, to check the version you have on the machine you're in. And if it says that you don't have one, that again, you have to go download and install it. But so here's the version, right? So this is version 2 of Git. So that's the major version. There's 25, means that they've done some minor changes 25 times, and they've done 1 patch fix. So Git version 2 won't work with Git version 1. Git version 25 should work with Git version 2.24. But we're at 2.25.1. Not super relevant, but we know that's what it is. All right, so we know we got Git.
Can I ask you something here?
Sure.
Okay, because we were talking before the class started, right? I kind of failed to connect to Git, right?
Mm-hmm.
How did Git get in my console here?
So that's what I mean, is that Python Anywhere already has it loaded and installed, right? So like if you don't have it, like if you're doing it on your own machine, you'd have to like download and install Git first. But that's just already done in Python Anywhere, right? So it exists. But there's just nothing, like it's not set up yet, but it's there.
Yeah, okay.
Cool. So let's do this. So there's a really common command to see what is going on with your files, your directories, and at what point you are in the workflow, right? To see if things are staged, if things are, like where they are, if they're unstaged or staged. And the way you do that is the command status. So we do git status. And I haven't done anything with Git yet, so I'm going to see what happens here. This shouldn't work because I do not have a Git what's called repository, right? So it says fatal, not a Git repository or a parent up to mount point home, blah, blah, blah. That means we have not started a repository yet. So although we have Git on our system, we haven't initialized a Git repository in this project. So we got to do that. It's the first step we got to do, right? So to do that, I'm going to clear this up to make it a little bit cleaner. And we're going to type git init, short for initialize, right? And it's going to initialize a Git repository when I hit enter on this. And it says initialized empty Git repository, and then it tells you where. So this is where it is. And you see that it says .git. That means this dot preceding Git is a hidden directory. So we just see that it's in there by doing our ls command. I like lining it up in a list, and I'm going to hit A to show the hidden directories and files. As you can see right here, it is a directory, right? So .git, it exists in our top level where we have everything else that we're used to seeing, our to-dos, our templates, and all those sorts of things. That is a directory. You can go in there and read it, look around, and if you really wanted to, you could do you know.
It's Git.
Mhm.
Oh, I know what I did.
You misspoke
Space
and
of
get
no, the wrong number of spaces.
that'll happen.
Now I
So if
get
you,
it.
so if you look in the Git directory, I mean, you're welcome to. There's no real reason to go in here, but it's there if you're curious. You can poke around in it. It's just a directory again. It's files and directories, just like every other piece of technology out there. So you can read these files, you can look at them, you can do stuff with it. There's no reason really to go in there most times, but that's all we did when we initialized it, right? So the main thing that I'm trying to draw attention to here is that we just put this Git directory in our project root directory, right? So top level of our project, and that is an initialized repository. So it is now ready to start tracking all these files and everything that's in these subdirectories. So now if we do git status, it's going to give us something. It's give us some information. So it says no commits yet. It says what branch we're on. So we're on branch master. We can see that it is following the old convention of naming things to master. So we're going to rename that to main. We have no commits yet, so we haven't saved anything. And we have untracked files, right? And it kind of tells you what to do here. So you don't have to even refer back to the documentation if you don't want to. It tells you exactly how to add these things. So you say git add and then file to include what will be committed, right? So these are all of our things that could possibly be committed. It says nothing added to commit, but untracked files present. Use git add to track, right? So this gives you all the steps, tells you everything you need to do. Before we do a commit and add anything, I've mentioned that this like looks at everything, saves everything, and grabs it all, and you put it up in the cloud and all that kind of stuff, except if you ignore things. So I emailed out earlier a file. It's called .gitignore, and we're going to add that here. And that is it is an explicit list of things that you do not want Git to take into its repository. And there's a lot of things you don't want to have in there. There's things like, let's go ahead and look. Your PyCache. Remember, we excluded that when we did our tree command. We don't want to save that stuff in our version control systems. Manifests, all these things are standard boilerplate stuff that you can find a gitignore example. I'll show you where you can find one on GitHub when you create a repository there. Most of these things come really standard boilerplate that you're going to see everywhere. You see our .env. We don't want to include that in version control because that's typically going to have sensitive information like secret keys and all that kind of stuff. You don't want to save those in there. That's publicly available information. It's accessible online if you push it up to a remote repository. So those typically are not involved. Virtual environments you don't save to version control systems. The way you tell other developers you might be collaborating with what packages you want to use in a virtual environment is just a text list that just says these are the packages. That's one way. Just one real common way to do it, because it's a lot smaller to just give you a list of things and then you go download those things instead of giving you all those things downloaded. And it's like, tons and tons of stuff. It'll take forever to get this repository downloaded, and we don't need that. So again, most of this, we're not going to read all through it. Some of this stuff is like project specific to our bigger project. This is actually the gitignore file that I use in our main project, but it's boilerplate down to about here, I think. This is all just regular stuff. So what I'm gonna do is I'm just gonna take all of this. I'm gonna copy it. I'm just gonna copy it. I'm gonna create a gitignore file with these things in there in this my site directory. So like alongside all these things, right? So it's not in the Git repository. It's not going to be in that Git thing. It's going to be in our my site directory, just like everything else in here is, right? So what we're going to do is I'm just going to do v, and I'm going to do .gitignore to create this file. And so, it doesn't have any file extensions. It's just dot and then the name gitignore, and it's going to expect it to be just this. So I'm going to hit I to hit the insert mode, and then I'll just paste all that stuff. Oh. Paste the wrong stuff. Apparently I copied my file directory and not this. So try this again. Actually copy everything this time and paste it in. There we go. All right. So now we got all of our gitignore information, all the things we do not want to commit into our Git repository saved in there. And I'm going to save this. I'm right command WQ. So I hit escape to get out, and then I hit WQ to save it. So now if I do
hang there for just a second, let me copy the syntax of the VI dot.
Yeah, and you could do that in the GUI in Python anywhere too if you just feel like making a file without using V. I just think it's easier to make V since I'm just pasting this time. But That's totally matter of preference for you. If you're more comfortable just doing it in the GUI, you can do that. Whatever you need to do, just put it in the top level directory and make sure this get ignore is in there because that's where it belongs.
So is it get ignore is that one word?
Yep. It's all lowercase and is preceded by a period. So it's just dot get ignore, all one word. All right. So now when I do get status, get ignore is included in the list of untracked files. So what I typically do, and was pretty standard, is that we would have, had we been doing the flow like a normal project, we would have started with a get repository before we wrote any of our code, right? Because this is kind of a higher level like thing, we obviously didn't start with writing a Git repository before we wrote our app, right? So, excuse me. So what I'm gonna do here is I'm not gonna add everything to this. So the command that we use for adding anything is add, right? It's telling you this here, says get, add, and then it tells you a file, right? So that's for adding one file. If you want to add everything, you can do get, add, and then period, and it'll get everything. We don't want to do that this time. We want to do one commit with just the get ignore. I want to be explicit. I'm going to use tab complete to make sure that I am in the right place, that it is right next to where I expect it to be, right? So I'm going to do get add, and I'm going to do just that file name that I want to add. The reason I want to do this is because I want to make sure I'm going to run through the adding to staging and then commit it to make our first commit because we have no commits yet. Make our first commit with just the get ignore in there. That way I'm positive it will be ignoring everything I want it to be ignoring from then on. Does that make sense?
So the ones that you highlighted from the setup page, right?
Mm-hmm. Mm-hmm. This page right here?
Yeah, that one. Okay.
Yeah.
The step where you add these to your console, right?
To the get ignore file. Yeah, I just copied and pasted those into this get ignore file. So it's so if we open up this file, it'll have the exact same style. I just pasted this up in there. So it's all this is just listed in that file. That's it.
When you got VI get ignore on your prompt there, right?
Mm-hmm.
You just press Control V and it'll be there.
I mean, yeah, you got to copy it. Do copy and then paste.
Yeah. Yeah. Okay.
All right. So now I'm going to add.
Oh, yes, there we are.
So I'm going to add this to the staging. So I'm going to add this get ignore to our staging, right? So we can picture that working directory staging thing. And it's not going to give me any information that it did that. It's going to give me my control back. So I'm going to clear this so we got some more space, and I'm going to do get status again to confirm that it did actually do what we wanted to do. So now it says new file, and it's in green. It says get.ignore, right? So the untracked files are in red, new ones are in green. If you have red-green color blindness, I apologize. There's the colors they use. But this says how you could pull these out of your stage thing. So if you ended up adding things you don't want to, this tells you how to remove it. So you should get rm -- cache. We're not going to mess with that because it pops up every time. So no need to remember that. It'll tell you this every single time you add something. So if you add more than you wanted to, you can remove it. But we added what we wanted to, right? So we're going to leave these untracked and we'll do our first commit. So now we've added this. This is the only file that's going to be committed. And that, again, is very typical for a first commit. Usually when you start a project, there's nothing in your directory yet, and you just have a get ignore. You might also add a license, which we'll talk a little bit about how you choose a license and why that's even relevant. And you might have a README doc. And those three documents typically are the only things you start a project with. Like, you don't usually have a whole bunch of other code in there, but when you start, you get repo. So now that we've added the file we want to add, and it's in our staging now. So that's, again, these are just in our working directory.
Can we back up for 1 second here?
This is in staging. Yep.
Okay. I've got all the file from the resources.
Uh-huh.
I forget how do you get to accept it, right? They got insert showing at the bottom, right?
Yeah, hit I to insert, and then hit escape to get out of insert.
Right.
And then hit colon to give a command, and then hit WQ to save it. Right. W is write and Q is quit. And hit WQ enter. So colon WQ is how you write in V.
I got this written down someplace, but okay, there we go. Okay.
Cool. All right, so now we're gonna do our first commit. So we do get commit. And remember the -M, and we have to pass it some sort of message. What is typical and standard on your first one is initial commit, because again, there should not be much in your initial commit. It's probably just going to be your get ignore, license, and readme, probably just those three things, right? If anything, it may not even be those. You just do like your initial commit with like I'm doing with just get ignore. So get commit M, initial commit. And I'm going to go ahead and do that. And it'll give me some information when it says, okay, master, root commit, initial commit, one file changed, 149 insertions, right? So that's all. This is 149 lines, I'm assuming. It tells you how many things were inserted with this little plus. If we remove something, it would say deletions, and it would show those minuses on there. And then it says create mode because it created the file. This wasn't a file that existed before in the Git repository, so it didn't update anything. It made it as far as Git is concerned. And now we've done our initial commit. So now we have that in our history in Git. It's in our repository. It's saved. So that is very simply the first flow. Like that's we added a file, we committed it. So we've done our initial commit. So now if we do our Git, if we do, this is a good one, Git log, and I like to add the one line flag just so it's a little cleaner. God, one line. Why am I not spelling properly? One line. There we go. And so this just, there is only one thing, but this gives us a number here and shows us this is the number of the commit. So when we add more commits and we have more of these, we can, this is one of the ways that we would be able to roll back is by referencing these things and check out one of these earlier commits. But this also gives us information on where those pointers are. So there's the head is pointing here. So that means that this is committed. And it is the same as what the master branch is, right? Again, we got to rename this branch. We'll do that here in a second. But we have our initial commit done, right? This doesn't show us the contents of it because I did the small version, but we can look more in the log and it'll show even more details about what this commit entailed all the way down the line if you wanted to. The one line flag makes it a little bit cleaner, smaller, and it just shows the basic info that we need. So that's basic, adding a file, committing it, setting it up there. Let's rename this master branch now while we're at it, just so we can before we forget. So again, to start, we do git, and then we do branch. And if you just do git branch by itself, that's a good command. It shows you a list of what branches you have, right? So we're going to make branches here in a minute, but we only have one branch now, and it has a little asterisk here, and it's in green that says the name of the branch that we are on, right? So if there are several branches, which we'll show in a second, it'll have the same thing to tell you where you're at, right? So git branch is good. But now if we give git branch some options, again, we're going to do M is the flag that we do to rename. And the syntax of this is we take the name that the branch that we want to rename, give it that. So master is the one that we want to rename, and then the name that we want to give it, right? So in this case, we want to change it to main because that's the standard, changing master to main. But this is true for any branch that you want to rename. If you want to rename a branch, this is how you do it. You do the name of the current branch and then the name you want it to be. And I hit enter, and now you can see that this little yellow thing here in the parentheses, which is the name of the branch that we're on, changed to main from master. And if I do git branch, it didn't make another branch. It just renamed that one. So we still only have one branch here. Cool. So that's real simple renaming. And we have our Git repository set up. And now if we want to add everything else to it, we can. We do git add everything. Well, let's look at the status first. So git status to recall. So we're on branch main, and then it says untracked files. Now it doesn't say no commits anymore because we have some commits. So there's a little bit less information, but it still shows you all these things that are untracked, right? So let's make sure that we do, first of all, that it had the git ignore got in there in the initial commit like it should have, and that it read it and actually ignored the things that we wanted to ignore. So if you recall, we go back to our git ignore example. There is a .env in here someplace that it is ignoring. So .env and the virtual environments and all these possible env things that might be in there should not be included. And we know that we have our ls.lha in our my site directory. There should be this .env file, right? And that's where we keep our environment variables. And we do not want to save that in version control. So it's in our git ignore. So let's add these other files that we do want to save, these other directories, our manage.py and the other things that we have in here, the rest of our code base. Let's add that, and then let's just ensure that it did not include .env. So to do that, we're going to do git add, and I'm going to do space, period, and that's going to be everything. So it's going to take everything, and it's going to add it. If it decides it wants to actually function and do that. I hit enter, and now it's just sitting there looking at me. All right, cool. So now it added everything. And so now if I do git status, it's going to be a lot of stuff on here real quick. Boom. So this is every file and everything that is saving, right? So this is the whole shebang. So I scroll up a little bit and find our my site directory. So here's my site. Here's our init.py that's in it. It's got the files that we know, the ASGI, the settings.py that we messed around with, our top level URLs.py, and our WSGI file that we didn't do anything with, but is there. But there is no .env file. It ignored it. So it's working the way we expect it to. That's good. And so again, the purpose of the staging part is to look at what is in there and make sure before you commit it up to your repository that you only have the stuff that you want to be committing to your repository. Because you can wind it back and take stuff out and delete it once it's saved and once it's committed. When I started doing this and I started using Git and I didn't know what I was doing, I did that all the time and I had to figure out how to remove things. It's really a pain. It's much easier to look at this ahead of time in staging and make sure you're only sending up the right things. Make sure you're getting or includes what you wanted to ignore, right? All right, so now we have those things in staging. We're ready to go. So let's do another commit. So we do git commit m, and then something to describe this. And this is going to follow the conventions of whatever project you're on, whoever you're working with. There's no real strict rules on how to do this, but it should be descriptive of what it is. So when you're looking at your log later, you can say, okay, that's the point at which I want to go back to. Like that's the place in time that I want to roll back to now that I've broken things, right? So you want to make sure that you're giving yourself enough information to know what's going on. So like I'll just do core application files. Doesn't really matter what we put in here for now because this isn't an actual live project that we're going to be messing around with a lot, but you got to put some sort of note in there. And once I hit enter on that, it's going to go through that same thing that tells me to create mode because all these files are new for the Git repository. So it's creating it in its log and saying, okay, these are the files that we're tracking. These are the files that we're looking at, right? So now we've done that. So now if we do git status, it should say on branch main, nothing to commit, working tree clean. Doesn't show any list of anything, right? So this means that we are good. So this is the place that you generally start from when you come in and start working on something. You start here from a nothing to commit stage and you start messing around with things. You start working, start making some changes. You have changes to commit. You go through that process of adding the changes, checking them out, staging, make sure it's the ones you want to commit, and then committing them with some sort of message explaining what you did. So that's the basic flow of adding files. That all make sense? Any questions so far?
Yeah. I'm gonna have to go through the video again.
It's gonna take practice, definitely. This is definitely gonna take practice. Yeah. This is absolutely something you gotta do. You're like, if you're not doing it now with me on this one, I do recommend it. But if you're not, if you're just listening now, you're gonna try it out later, that's fine. But try it out. It makes a lot more sense when you do it, right?
Oh yeah, always.
Yeah. So cool. All right. So let's do some basic branching and show sort of what that looks like and what it does and go through that process real quick. Do that again. We're going to use the branch command. It's very simple. So we do git. Oh, I'm sorry. You don't use branch. We use checkout, the command checkout. So this is how you move from one branch to another once you have multiple branches. This is also how you create a branch by giving it the B flag. So you git checkout space -b, lowercase b, and then the name of the branch that you want to give it, right? So we could give it any name we want to. We could even do feature X, like in the example, right? It makes no difference what we call it. When we do this, it's going to say switch to new branch feature X. Now we're on that new branch, right? So it at this moment is exactly the same as the main branch. There is no difference. There's actually a way to look at differences. You can do git diff and then I think main. And there's no differences, right? So let's make a change to something. Just change any file. Honestly, makes no difference what file, but let's just make a change, something small. I'm going to change the base base.html. I'm just going to add something to it real quick as an example to show that the change that I make here will exist in the feature X branch, but it won't exist in the main branch. So I just opened this up in V. You can do it however you like. Really makes no difference on how you get here. You can open up with a GUI if you like, but I'm just going to add something in our insert mode first, and then under the block, I'll just say a paragraph. So again, this isn't real code that I want to save forever. This is just demonstrating that once I save this in here, let's say I added a paragraph into this template, I'm going to right quit, put this out here. So now in my feature X branch, I have made a change to the base template. So if I do git status like we did before, it'll show me that modified templates base.html. So if I do git add all, I'm gonna do all, even though there's only one change. It's just a good habit to just hit period and get everything in there. It's usually the case that you want to do. You want to do git, you want to save all the changes that you made usually, right? I'm not going to check the status again because it's one thing and we're good. So I'm just going to go straight to the commit. And I'll just do updated base HTML. Makes no difference, but required to put some sort of thing in there. Right. Cool. So now this tells us that this is the hash of the thing that we changed. This is the branch that we were on and the changes that were made, right? So one file change, one insertion. So let's prove that that is not on the main feature. So check this out. I'm going to do git checkout to change back to our main branch, right? And I can tell that we are. So it says switch to branch and it says main here in the parentheses. I'm going to clean this up a little bit, clear this. And now I'm going to go into that same base.html file and have a look. And as you can see right here, underneath this end block, right here on row 19, this is where I added that paragraph. It is not here. So there's no paragraph here. So it did not add to our main branch yet. So if I get out of here, don't have to save anything because I didn't make any changes. And then let's go back to our other branch, our feature X branch. I'm just going to use up to get back to the same spot. And there you can see it's in there. So it's in the feature, but it's saved in the branch because I committed it. So it's saved in our feature X branch, this I'm a paragraph thing on row 20, but it did not on our main branch. So if we want this to be committed to our main branch, then we have to do what's called merge. So to merge, so let's assume that this is, something more complex. We actually add a new feature. Once we're done with all of our work and we're ready to go and we've committed it here, so we have no, the working tree, as they call it, is clean. So working tree clean, nothing to commit. We're going to check out our main branch, the branch that we want to merge this into. So again, if you imagine that picture where it had the master branch at the bottom, then feature X, and then it came back down into the master branch. So we want to go back to our main branch by checking it out. And then we're just going to do git merge, and then the name of the branch we want to merge into this branch, right? So feature X is the one we want to merge into this. And it'll give us this information. Said, all right, cool, we did that. It says fast forward and template. This has one addition, and these are the changes that have been made. So if we now on our main branch, that you can see here, we're on the main branch still. And if I go have a look at my base template, that paragraph is there. So we have now made that change in our main branch, and it is good to go. So that is branching and merging. It's very simple. You check out a new branch, you make it, do whatever changes you want to do, and then you merge it into whatever branch you want to merge it into. That all making sense?
Yeah, I get the concept.
Okay, cool. All right. So this is all real basic stuff. And from here, if you wanted to, you could save this and push it up into GitHub and make a repository and do all those sorts of things in a cloud environment and then start interacting with it. So if you haven't set up your SSH, this will be the time where we're going to start doing that. I'm going to pull down a project that we have in our GitHub and run it here and make a change and send it back and go through the process, show what's called a pull request and make sure clear on what that is, because this is the thing that I want you all to be able to understand and do. And hopefully you get to the point where you're comfortable trying this out with our repositories, with this repository that I'm going to show you here. That's a poker game that I made for this purpose. That's like a training environment for people to use, play around with, make changes to, practice the pull request, because it's us on the other side. So it's, you can find these things on GitHub and find anybody's project that's open and work with it. But this is our GitHub page. We have a handful of repositories. This is our main thing. So again, this is all public. It's all open source. And just as a side note, open source just means that you can read the source code. It doesn't mean that it's free. You can have a fully commercial enterprise that makes money off of what they do, and their source code can be open source. There's a place called Supabase that's something like Python Anywhere. So like a way for hosting and stuff like that. And they're fully open source. And the founder of that wrote a really good article about why they're open source. And he makes a good case about open source and what it's for. But main thing is to remember that it doesn't mean free. Open source doesn't mean free. It just means it's available, right? So we're going to use this Bootcamp poker game as an example of a repository, and we're going to go through the mechanics of pulling it down into our Python Anywhere instance, running it, making a change, and pushing it back up here for a pull request, right? And I'm going to explain what that is, why they call it a pull request. But this is the collaborative coding piece. So this is how you would work if you wanted to work on someone else's project, hopefully on our project. But if you go to GitHub, you can search up other projects. There are projects that are good for beginners. You can look by, whatever language you want to use, by Python or something like that, and find projects to contribute to that are open and public. But when we go here, if you haven't been in a GitHub repository, this is generally what it is. It is the actual code, right? So this is a public repository. You can just go here and see the code itself. So this is very basic, purely Python. You can see down here on the right-hand side, it says what languages are used in this particular project, and it says 100% Python. So there's nothing else to this. You can actually look at the code itself in here without doing anything, without downloading it at all. So this is the full code. It's kind of a beast. It's one page of a whole bunch of classes and a bunch of stuff going on here. And we're going to pull this down and run it. But again, you see that we have a git ignore. We have a license, which I think I used, GNU, real common license to use. And then I have a README. But if we just go back to our code, this is the README file right here. It's written in what's called Markdown, which is kind of like a simplified version of HTML that gives you these bold and stuff like that. And we can make edits to this right here. We can just make changes directly in here and not do anything else. But we're going to do what this says right here, the clone the repository under the installation step. So we're going to follow this step right here and do what's called git clone. So we're going to clone this repository. And you can do this with most repositories. You can clone them. You could also do what's called fork, but we're going to clone. So up here where it says code and this green button, there are several options of how to get to this, right? So the SSH is the thing that I asked you to set up beforehand for class to follow along this section if you wanted to. If you didn't get to set that up, it's okay. That's fine. HTTPS is another way to do it, but this is being done away with, so it's kind of spotty and they discourage you from using it. But all we have to do is we click on this green button, we go to this SSH let's have thing, and then this whole thing right here is what we need. So I'm going to copy this to a clipboard, and I'm going to go back to my console, and I'm going to clone this repository into my console. So before I do that, I'm going to get out of this project because we're not doing anything in this project. We're going to work on a new project now. Not really a full-on project. I'm not going to do the full, environments and all that kind of stuff. But let's start by moving out of this directory. So we just go home. And as I did that, you see the Git directory disappeared. So we're no longer in our Git thing. If I do Git status, it's not a repository because I'm in my home directory now. And this isn't a Git repository anymore. So we've left the Git repository. I'm also going to deactivate our virtual environment for that one project because we're doing a different project now. We don't need that. All right. So now when we clone something, what's going to happen is it's going to take the top level directory of here. So basically a directory that we can't see here because it is the directory we're in right now. It's just going to have all these things in it. So it's going to be called Bootcamp Poker Game / and then it's just going to have all this stuff in it. So let's do that. So we do git clone, and then I just forget that every time I highlight something in Python Anywhere, it copies it. So I'm going to take, again, this copied thing from the SSH underneath the code button on GitHub. I'm going to copy this whole thing right here, which is really just GitHub at github.com, and then the name of the organization and the name of the repository, which we can see here. So it says git clone, does all this stuff, name of the repository that you want to clone. And it'll do that for a second. And then let's see if I can remember my password without saying it out loud, which I typically do. And I don't want to record my password. So there we go. So now it says that it did that, gives you the information on each step that it did. We'll clear this up. And then now if I do my list of what's in there, we can see there's a directory for the Bootcamp poker game, right? So let's go ahead and move into that directory. Clear this up. And you notice when I moved into that directory, main popped up because this is a Git repository. We cloned this from GitHub. It is already a Git repository. It's already set up that way. So now if I do lslh, I should have those 3 files. Oh, I forgot to get the git ignore. Sorry, lha to get our git ignore. And as you can see, it also has the Git directory in here, right? So this is the Git repository, and here's our git ignore file. So that does save and come down. Then there's our license readme and main.py, which is exactly what we've got over here. So these 4 files are copied right here. And if we open up this main.py, it's going to be exactly the same stuff that is in here. Oh, that's just one of the changes. Sorry, I clicked on the actual change link, not the file itself. It'll just look like this. If we open it up, it'll be exactly the same stuff. Right. So now, we're not gonna go through this. Isn't a course about this game, but the way you use this, if you want to run this, and I do encourage you seriously to run this. It's very simple. It's gonna be the same way that we've done our other things. We do Python 3 main.py. I'm gonna zoom out a little bit because it's supposed to fit our normal screen. But then this is gonna go through a game, poker game, where it has some AI players. So here's me. I gotta make it a little bit smaller to kind of fit the screen. But here's me with a handful of AI players, and there's no cards. It gives me some choices, so I can try playing a hand, and it'll just kind of like run through and do some stuff. And it dealt me out some cards. I got a king of diamonds. I got queen of diamonds. Nice. So I got king queen suited. That's a good hand to start with Texas Hold'em if you're not familiar with the game. We're not gonna go through this whole thing. This is all sorts of buggy, but basically each one of these AI players is placing a bet or calling a blind or doing something, and the action is moving around the table. And this is all Python. So I encourage you all to go in here and mess around with this, make some changes to it if you want to. It's all classes and it's user recursion, and it's a lot of stuff that we talked about up to now. But so now what I've done is I've just pulled this down from GitHub, and I have a fully running program here. I didn't do anything else other than that, right? So we're not going to go through playing a full hand, but this is the game. So I'm going to exit this by hitting Control C. It'll break that. Oop, zoom back in so we can see a little bit more what's going on. Let's clear this up. All right, so now we've got our repository, right? So let's just assume that I want to make some changes to this. I want to do something to it. And so I want to go through what's called a pull request. And it's called a pull request because from the perspective of the main branch, I'm going to make some changes, and then I'm going to ask that the people who run this project pull it into their main branch, right? So this is where the collaborative coding comes in. This is it's just me doing this right now, and this isn't something I would do when I'm working on my own. But when you work with other people, this is exactly how we do it. So I'm going to go through those steps. It could be a little bit contrived because it's just me, but imagine there's kind of two people doing it, right? So imagine somebody else wrote this game, and I'm a developer on the team, and I'm working on it, right? So I'm just sitting in a position as a developer. I pulled down the source code, and now I'm going to start working. So I know I'm on the main branch, and so what I want to do is I want to make a new branch that I can start messing around with, right? So we do that the way we did before. Get checkout, give it the B flag, says new branch, and then we can give it, again, whatever we want to. So we could do, I don't know, feature A. Who cares? So now we switch to feature A. All right. So now if I want to make a change to something, I'm just going to make a change to the README because it's simple. And just so we have something to do, that's an example. It doesn't have to be, I'm not going to go through the Python or anything like that. Let's just say AI players. I'll just add a note in here that says that it's Python only. Whatever, doesn't matter. Let's just imagine that was a super important thing that we needed to add to this README, and now we've done it. So we've done our job as a developer. And again, this is also fully fine. Like if you want to try this out and practice doing pull requests with us, which I encourage you to do, changing a README file is absolutely fine. You're not going to break any of the code doing that, right? So do that to get through the mechanics. All right, so now I've done that. I've made a change here. So if I do get status, it's going to say, all right, you modified the README file. So I'm going to do get add.
Hey Jeff, one second.
Yep.
Sorry, I just did a poll. I just cloned your repo, and while you're doing that, I was also gonna do the same thing. I wanted to ask, and I'm not sure if you're gonna cover this, how, as you're doing this and as you're about to push it right into the repo, what can I do to make sure that I guess the repos that I clone are up to date? Do I
love it. Yeah, that's a good question.
Get status every time?
Yeah. So usually when you start, you want to do a pull, right? So you clone it first, and then once you've cloned it, that'll be the most up to date. And then it's like, say you work on it for a little while, and then you put it down, you come back the next day. Like when you start your day, you should start with a pull, just to make sure you got the most up to date stuff. But yeah, good question. Good question.
Okay. Thank you.
Cool. Yeah, no worries. And if you are following along, it's good. I'm glad you're following along. If you're following along, we shouldn't have any conflicts, but it'll be interesting. I'll go back to GitHub and we'll see.
Okay.
But all right, so now if I do get status, again, just check. We've added the README file. So what I'm going to do is I'm going to push this up to GitHub. But last time well, no, we didn't do that last time. So last time we did, at this point, we merged it right away into main. So again, let's imagine that I'm not the owner of this project. I'm just a developer on it. So I don't have access to main. I can't merge to main. There's organizational levers that tell me not to do that. So I can't break the main source code. It has to go through somebody else checking it first. So the way we do this, the way we work is I'm going to push this branch up to GitHub, and it will then allow me to make a pull request, which will, again, go to somebody that runs the project and encourage them to pull it into the main branch. So let's do that. So the way we do this is we're going to do, first I'm going to clear this up so we got a little bit more space. We're going to do git push and then origin, which is the repo on GitHub. That's what origin means. It's the remote spot up on the cloud environment, right? It's always called origin. So git push origin, and then we say what we want to push up there. So we're going to do feature A. So this branch is what we want to push up there. So we do git push origin and then the feature or the branch name that we want to use, feature A in our case, or in my case. It's going to ask for my passphrase again. And again, I will try not to say it out loud as I'm recording myself. All right, so when I do that and I push it, this time it's going to give me some more information like it always does, but this time it's going to say create a pull request for feature A on GitHub by going here and saying, okay, cool. So I already have GitHub open, so let's have a look at what GitHub says. And it says new branch right here. It says new branch feature A to feature A. This is just saying that I push it up to, again, the remote place. So but from our local environment to the remote one. All right, so now if I go back to the main code part, there should be no. Here we go. Branches. Cool. So here are our branches. And this is the feature that I just pushed up here, right? So there's feature A. This is one from last class when they changed one. If I hit feature A and click on this, it's going to take me here. It's going to show me all these differences. So now I'm on this branch. I can look around at this and I can go around to different branches. But if we do pull requests, we say new pull request. So up here at the top, next to code, the issues, then pull request. I'm going to do a new pull request. And so up here it says compare changes, right? So this has two branches where it says main and main. So it says choose different branches or forks to compare, right? So here's example comparisons, some stuff to do. So after checking the second drop down, I'm going to check our feature A. It says there's nothing to compare. Main and feature A are identical. What did I do wrong here? Did I not save that change? I did. Why is it not giving me a pull request? Okay, so let's try this again. That should have showed me the difference. What did I forget? Anybody following? Catch what I forgot here? I missed something. I missed a step. And it's telling me there's nothing to compare because it's the same. Why would they be the same?
You didn't upload it, push it, right?
Yeah, I didn't commit it first. I pushed it. I pushed it without committing. I skipped the commit step. Naughty, naughty, right? And we can tell because they're just in stage, right? So here it is. It's staged. So we have to do git commit with a flag. Can't believe I missed that step. It's add then commit. I know that and I didn't. All right, so we'll just do updated readme. Boom. Actually, I'm gonna navigate back to this real quick because this should just show me that there was a new pull request when I do this, right? So git commit m update readme. Boom. Cool. Now we'll go back up to just the git push origin feature A. Now that branch is already on there. And this is going to say, okay, this is some, give me the passcode again. Cool. Now we should have this little flag that popped up. When I go back to GitHub, this is what I was looking for originally. And it says right here on the top in bright yellow, it says feature A had recent pushes 3 seconds ago. Compare and pull request. So that means that there's some different stuff in there on the branch, some changes made to it. And now if I click on this button, again, this is from the standpoint of, you know, somebody trying to work together on this, right? So imagine there's more than one person doing this. This is not something I would do on my own if I'm just working my own project. But now I can make this pull request. And what this does is I can add some more descriptive stuff in here, be like, made the README file better or whatever, right? And then I hit create pull request. And this is going to give me an opportunity. It's going to check for the ability to merge directly here. I can just click this button to do different stuff. We can chat back and forth on this. You know, if it's, again, assuming this is more than one person doing it, we can discuss the changes. We can discuss how, if we're going to commit it, if we're going to merge it, we're going to do all those things. So I could just click this button and merge it here, but I'm going to show you how to do it from the command line. Again, assuming that I am now the other person who has pulled down this branch, and I've tried it on my own local environment, because that's generally the flow, right? Like one developer will develop the change, push it up like I just did, create this pull request, which again is asking the owner of the repository to pull it into the main branch. And then now I am now that other person, the owner of it, in my thing, and I've pulled down this feature A branch that they made. And I checked it out and I ran some tests and I did all the stuff that I want to do. So now on my end, I'm going to do the merge like we did before. So I'm going to check out main. So get check out main, switch to branch main. And then we're going to do get merge that feature A that we just made. And it's going to give us the same stuff we did before with all the updates and whatnot that we changed. And then we're just going to push this main branch up to our cloud repository, right? So get push origin main, all lowercase. Once again, with the passphrase that I will not read out loud. And now when we go back to GitHub, it should say that that was already done. So all those buttons and everything about merging should disappear. So there it says pull request successfully merged and closed, right? So you're all set. Feature A branch can now safely be deleted, which means that when we merged it, it didn't go anywhere. So if I go back to my thing and I do get branch to list our branches that we have available, we'll still see the feature A is still there. It's totally untouched. It's exactly what it was, right? But now there's no difference between main and feature. They're the same. They got the same code at this moment. If we go and start making more changes, if we make changes to main, or if we make changes to feature A, they are no way connected to each other anymore. So we can further develop feature A, and it will no longer match main until we merge them again. So that is the basics, a very, very quick crash course in how Git works, what it's doing, the basic mechanics and features that you're going to use frequently, and then how to do it collaboratively through GitHub specifically, how to do a pull request, what a pull request is, what that means. And we are just about on time on what I wanted to do. So we got a few minutes for questions. Does anybody have any questions about what we did up to there? Cody, were you able to follow along? And I don't see any pushes up here. Are you going to push a new branch?
I didn't have any permissions.
Oh, you should be able to. Oh, this should be public though. You can't push a branch up here?
No. It gave me error permission to hired labs bootcamp get denied to CK hired labs. Could not read from remote repository. Make sure you have correct access permissions.
Okay, all right. Maybe I have to update and add you on here. All right. Well, we can mess that later. But you went through the steps. I'll figure out how to make sure that you can actually add it there. I thought I made this available for everyone to do it, but I'll check. Maybe I got some kind of permission here that's stopping you.
No worries. Actually, I do have one question.
Yeah.
What
shoot.
if I gone through the Git add and I want to remove my feature that I had added because I have yet to commit the file, right?
Sure.
So how would I remove that branch?
Do you want to remove the entire branch or just the changes that you staged without committing them?
Probably the latter.
So you just want to remove from staging the changes that you made, but keep the branch?
No, I want to remove the branch.
You want to delete the branch entirely?
Yeah.
Okay, cool. So All right, I'll show you how to do that.
Okay.
You get. I'm gonna go back to my main branch. So I'm on main now, and then you're just gonna do get branch, and then I use a capital D because I'm pretty sure that forces it, but I think lowercase d will work as well. It's just for delete, right? So get branch dash D, and then the name of the branch you want to get rid of. So feature A in my case, and then there you go.
Okay.
So now it's gone, and then I can check my branch list, and it's just main.
Got it. I was typing in RM and
yeah. RM is the way you unstage a change.
Okay.
So like if you add, like after you do add, if you add something and you're like, oh no, I don't want that file in there, that's what you use RM for.
Gotcha.
Yeah. Okay. Cool. Good question. Any other questions? No? All right. So I apparently have to go check the settings to make sure that you can collaborate with us. So Cody, I'm sorry that you ran into that roadblock, but I do appreciate you trying. And I'm going to go make sure that that's right. And I do encourage everyone to try pulling it down, send in a pull request, make it some kind of change. Doesn't really matter what kind of change. But definitely use the Python stuff as practice as well. And then I would love it, again, if you all wanted to take further steps of learning things like Docker. If you're not familiar with Docker, we don't cover in this course. It's a little bit outside of scope of this one, but it's exceptionally cool. And we use that in our main project. So a little slippery of an idea, but it's kind of like an entire environment into one file, basically. It's really cool. So Docker's great. If you got time, check that out. But this bootcamp poker game is pure Python. There's nothing really crazy in it. And I fully encourage you all to at least pull it down and play around with it. And again, I'll update the settings to make sure that you can send us pull requests so you can practice those mechanics as well and see us as, like us, right? So if you have questions on how the pull request works or you get stuck somewhere, this is the end of the course. We're done. But you are all still welcome to contact me or the rest of my team and ask us questions, connect with us on any of this stuff.
Appreciate it. Thank you.
Yeah.
So I have a feeling I'm gonna come up with some questions.
Yeah. Yep. And it's, a lot of these things, seriously, I feel like I know them. And then 2 minutes later, I'm like, I have no idea how this works. So
yeah, I have that feeling. Yeah.
All right, great. Well, so with that, then we're going to wrap up and we're going to be running another one of these courses here September. So you're all welcome to come back and do it again if you like. We'll be doing some like higher level stuff around machine learning and that sort of thing, natural language processing, that sort of stuff. If you're interested in those sorts of things and you got these mechanics down, know how to use Python, definitely encourage you to take that once we have that course baked out and ready to go. And I mentioned this a few times before, but the other side of our business, the resume rewrites and the tailored job search, we'll be reaching out to you as we can get people into capacity. Because again, we're a small organization. We're trying to scale out. We just can't handle everybody on that one right now. So if you haven't worked with us on that already and you're interested, we will be following up with you. But feel free to reach out to us, either info@hiredlabs.org or me directly, however you like, and we can go from there.
All right.
But good. All right. The only other thing you're going to get from me about this particular course is feedback request. So please give me your feedback. Okay. When you get that.
I will.
All right. Thanks a lot, y'all.
All right. Thanks, Jeff.
Yep.